Hello, so this is section 3 of 2018 AMC paper for middle primary. I've included the links up here for question number 1 to 10, section 1, and question number 11 to 20 in section 2. You can visit those sections. In this section, we will be solving question number 21 to 25, which are 5 marks each. And since this is section 3, these questions are a little bit more tricky than the previous questions. So do be ready to have a little bit more working out and explanation to find the answer. All right, so question number 21. 6 small eggs weigh the same as 5 medium eggs. Let me highlight it. So 6 small eggs are the same as 5 medium. 6 medium eggs weigh the same as 4 large eggs. It's always recommended to highlight important information so that you don't miss out. How many small eggs would weigh the same as 5 large eggs? So this is a little bit more information, so let's write it down. So we have 3 kinds of egg: small, medium, and large. Now, according to the information, 6 small eggs are the same as 5 medium eggs. So 6 small eggs weigh the same as 5 mediums, all right? And according to the second piece of information, 6 medium eggs weigh the same as 4 large. So 6 medium eggs, if this was a weighing scale, this would be equal to 4 large. Now, in the question, they're asking us a relationship between the small eggs and the large eggs in these two categories. We don't have a direct link, but we have a link between small and medium, and we also have a link between medium and large, and we can manipulate the numbers to find the link between small and large. Now, 6 small is 5 equal to 5 medium. 6 medium equals to 4 large. If we can get the number here to be the same, then we can develop a relation between small and large. Now, how can I change this number to be the same? What number can it be that I can get this ratio to work out and this ratio to work out so these two numbers are the same? Let me change the color of my pen. All right, yes, you can take the least common multiple, and the least common multiple of 5 and 6 is 30, because 30 is the smallest number which can be in 6's time table as well as in 5 times table. It's a multiple of 5 and 6. So I can write 30 here. I do want 30 here for both my ratios. All right, so coming from here, how can I get a 30 here? If I can multiply my whole ratio by 6. So 6 times 6 is, let me extend these lines. 6 times 6 is 36, and 5 times 6 is 30. That is what was intended. Now for the second one, here, we already have a 6 in the medium, so we need to multiply this ratio by 5. So 6 times 5 is 30, that's already written, and 4 times 5 is 20. And now we can see we have the same number in the medium range. So direct relation between small and large is 36 small will be equals to 20 large. 36 small will be equal to 20 large, but they're not asking us that. They're asking us how much will 5 large x equate to in small x. So I don't want 20 here. I do want 5 large x. I do want 5 here. What can I do? I can divide this by 4 to get a 5. I can divide this by 4, and that will be 9 to maintain the ratio. That means 9 small x will equate to 5 large x, and that's our answer. Here it is, D. We found the answer. 9 small x can weigh equals to 5 large x. All right, question number 22. Pictures of fruits have been placed in this grid to represent numbers less than 10. So we know each fruit can only represent numbers between 1 and 10. There are 4 kinds of fruits. We can see apple, we can see bananas, pear, and oranges. There are 4 kinds of fruits. The total for each row and column are shown. I can see the totals here, and these will help us find out the answer. What is the total value of an apple, and an orange. So we want to find the value of all apple as well and orange as well to find out the answer. All right, let's start. So look at all the rows and the columns, and the easiest one you will spot to find is working with row number 1. Row number 1 is 4 apples, and 4 apples equate to 24. 4 apples, I will just write 8 for apples. 4 apples equals to 24, which means A equals to 6. We found the value of apple. Apple is 6. All right, moving on. Now let's look which one will be the next easiest one to find, and I can already spot it that row number 2 will be the next easiest one because it just has apples and banana. So I can find the value of bananas from there. So 2 apples, I already know apple is 6, so 2 apples will be 12. 12 plus something will make it 22, so that means these bananas should be 10. 10 from 2 bananas, that means each banana equals to 5. All right, so I found the value of apple, we found value of banana. Now let's find the value of some other fruit. Now if I go on to row number 3, that includes all the 4 fruits, and that will not be easy to work out right now at this stage. So let's start looking at columns, and I already found a column. Look at column number 1. This has apples, bananas, and pears. So there are 2. So sorry. That was by mistake. All right, coming back. So looking at column number 1, there are apples, banana, and pear. We already know for apples and bananas, so finding pear would be easy. So 2 apples are 12, 1 banana is 5, so 12 plus 5 is 17, and something more will make it 21. So pear should be equals to 12 plus 17, 4. So pear must be equals to 4. Banana was 5. And now we are just left with orange to work out. So we can look at, now actually you can look at any of the rows or the columns and it will give you the answer. But just because I'm on columns, let's work on column number 2. All right, so 2 apples, 12. Pear is 4, 12 plus 4 is 16, but the total here should be 19. So that means orange must be equals to 3. And we have worked out the value for all the fruits. And now let's read the question again. What were they asking? They were asking the value of an orange and an apple. So apple is 6, orange is 3, so together they make 9. So our answer is B. 9. All right, now this is an interesting question and which will require the knowledge of area as well as shapes. All right, Warren drew 2 large squares. I can see 2 large squares here. Let me draw them. These are the 2 squares that overlap to form a hexagon. Now remember, this is not a regular hexagon. This is just a shape with 6 sides. Let me just draw it for you so that you can see it clearly. First side, second, third, fourth, fifth, and sixth. So this is the hexagon that he has managed to draw using the 2 overlapping squares. All right. The area of each small square is 1 centimeter. In square centimeters, let me just mark it. Each small one, that means each little one here is 1 square centimeter. In square centimeters, what is the total area of the hexagon that Warren has drawn? Now, of course, because these are 2 overlapping squares, so the area of the first square plus the area of second square would be the area of the hexagon. But look at this part. There is a part that is overlapping. That means that area was in the hexagon was previously covered by 2 of the squares. That means we are counting this area twice, and we cannot do that, so we have to deduct from the total area of this plus the total area of this square, take away area which is overlapping, because we are counting this overlapping area twice. So now counting the total area of the squares is not a difficult job. This square, I can see there's 1, 2, 3, 4, 5, 6. Is 1, 2, 3, 4, 5, 6. This is a 6 by 6 square. So the area of one of those squares is 36 square centimeter. So two of those squares join together to make 72 square centimeter. All right, let me write that down. And now we just have to find the area of the overlapped part so that we can deduct it from 72 and find our answer. Now, don't try to actually work out a calculation and find using a formula. This can be approximation, because in the answers, if you see, the answers are very wide apart: 12, 36, 48, 60, 72. Actually, we already know this is not going to be 72, because 72 is quite high and 12 seems too low. So we only have actually 3 answers and they're very wide apart. So we don't need to find the exact answer. If we can find approximation, that will work too. So let me grab my highlighter. No, first let me zoom in a little bit more. Mark the area of the overlap that we are looking at. All right, now this area is covered by two lines, so you have to adjust your eyes so that you can see only one side of the squares. So I'm planning to look at the squares that are coming, the little squares that are coming from this square. So let's count. I'm going to count the little squares. That's 1. Oh, okay, let me do it again. That's quite big. 1. I'm counting the full squares. 1, 2, since I know the area of each little square is 1 square centimeter, so that's 2 square centimeters. 3, 4. Now this one, there's a little part that's cut off, but it's a little bit, and I can count it as 5. Remember, we are doing an approximation, not finding exact. 5, 6, 7, 8, 9. Now there are 9 actually total ones, but I can see that, let me grab a different color. This part here, this square here, and this square here together, they make 1. So before we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and these two together make 1, so 10. I can think this little one and this little one make another whole, so that's 11. And this make another whole, so that's 12. Let's see. So there are 12 squares which are overlapping with each other. So before we had 72, we have to take 12 away which are overlapping. That's 60. Oh, actually we found exact. This is 60. The answer is 60 square centimeters. All right, question number 24. Again, a very interesting question which requires a little bit of visualization, a little bit of working out, imagining it, representing it, and then finding your answer. Let's read. Beginning with a row of 20 coins, let me mark, we are 20 coins. Anne takes the first coin and then every 4th coin. So Anne is interested in first and 4th. From the remaining coins, Brenda takes the first coin and every 3rd coin after that. Let me change the color. And from the remaining coins, Chen is taking the first coin and every 2nd coin after that. There's another person, Dimitri, take all remaining coins. So we can see there are 1, 2, 4 people. Yeah, there are 4 people in this. Does anybody get more coins than all others? Now, for this to work out, it's very difficult to work it out in your head. It's because there are just 20 coins. It's much easier to lay out the coins in front of you. So I will just make 20 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You could have drawn just lines, tally marks, anything, but it was just 20, so I prefer drawing 20 circles for the 20 coins. Yes, there are 20 coins. All right, let's start with Anne because she's the first one to go. She takes every 1st and the 4th coin. So let's mark the coins that Anne takes. So she takes the first coin and the 4th coin. 1, 2, 1, 2, 3, 4. She takes this coin, and then the fourth one, and this one, and then this one, and then she can't take any other because there's no fourth left after that. So Anne got to take, how many coins for Anne? 1, 2, 3, 4, 5. So Anne got 5 coins. All right, let's go on to the next person. Next person is Brenda. Let's take the same color what we chose before. So Brenda takes the first coin and every third coin after that. Now remember, the yellow coins are gone from the series, so we are not counting that. So this is the first coin in the series now. She takes this coin and every third coin. So let's count 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And she takes all the coins that are marked with. These are just my marks. I can remove that so that it doesn't interfere with our working. All right, so how many coins did Brenda take? 1, 2, 3, 4, 5. All right, Brenda also got 5. Now let's go for the next person. So next person is Chen, and he takes the first coin and every second coin. Remember, all these yellow and blue coins are gone now. So the first coin and every second coin. 1, 1, 2. 1, sorry. 1, 2, 1, 2, 1, 2. So these are all the coins that Chen can take. So how many coins did Chen get? Chen also got 5 coins. Now the next person is Dimitri. Dimitri take all remaining coins. So whichever coins are remaining, 1, 2, 3, 4, 5. And see what has happened. Dimitri also got 5 coins, and we have laid it out, and there is no confusion. There is no way of getting it all wrong. Let's look at the options. Which option is correct? So does anybody get more coins than the others? Of course, we have seen that all got the same number of coins, and that is answer number E. They all get the same number of coins. Our answer is E. So do you see, sometimes laying it out like this in front of you instead of thinking about factors and how many coins are remaining is much, much easier. All right, this is again a question which requires a little bit of perception and a little bit of understanding and visualization. All right, let's read. Yasmin has a 20 by 20 square of paper, centimeter square of paper that is colored on one side. So one side is colored purple, the other side is white. And we can see it in the diagram. This, let me mark it. So this is 20 by 20. So each side is 20. All right. She folds over a strip along each edge to make a white square with a 8 by 8 centimeter colored square inside. How far from each square is the fold? Now, for you to understand this, remember, she is starting with a square here, and we can see the little folds, the marks. So when she folds over the strip here, this is going to fold over and come here. This will land here because the top strip will come on the bottom strip like this, so it will come here. Similarly, the strip here, when she folds, the strip will come here, and it will hide all the purple all this purple space. Let me remove this. Similarly, when you think about this, when this strips fold over, it will come here. When this strips fold over, it will come here. So finally, if you think about it, the only part that will be visible in purple will be this little part. And this little part, as in the question, it told us it's 8 centimeter by 8 centimeter. So if you don't understand, try to grab a square piece of paper, fold along the edges and see how does it work out. Now, all right, so in this, on the side, sorry. All right, let's try to, I will try to make a square to replicate where it came from. So there was a bigger square here. There was a bigger square here, and then we folded over these strips that you can see here. This little strip came from here. This strip came from here. And similarly, you can keep going on. So this strip came from here, this folded along. And then the other one, let me just make one more, and this part folded from this side, as we talked about in before. Okay. All right. Now, I hope that is clear for you. So initially we had 20 centimeter. And now, after the folding, this side has folded over it 2 times. And this side has folded over it 2 times. So the final one that is left is 8. So how much of it has gone? Let me work it out here. So there was 20 and something was taken away from it, and now the remaining length of the square is 8. Of course, how much is gone? We can work out 12 centimeters is gone. But to take away that 12 centimeter, how many strips have been taken away? Of how many strips of those centimeters? Let's mark it. So remember, one strip here, one strip that was folded on top of this, one strip here, and then this strip was folded on top of it. So 4 equal sections were folded, deducted from 20 to get this 8. So that means this should come from 4 different strips of equal length. So 12 divided by 4 is 3, and that means, if I can remove all this, that means each little bit here should have been 3. So this is again 3, this is 3, and this is 3. Oh, sorry, this is not 13. This is just, I'm marking the space. So this is 3, 3, 3, 3. So that is the way 12 is taken off, and that is how we get 8 centimeter. So our answer is, where is 3? Our answer is 3 centimeter, and that is the end of section 3, question 25. We do have more questions 26 to 30, and that will be covered in section 4. Above here you can see the link to section 4, and these are, section 4 is some of the trickiest problems in all the AMC papers, so it will require a lot of understanding, lot of working out, so be ready with a paper and a pen. All right, see you there. Bye bye, take care.